Hello and welcome back to our channel.
Now let's come to the interesting part of square roots. So we have talked about squares and how we calculate them, their interesting properties, and some very interesting patterns that come out of it. Now it's time to understand the inverse of it. So previously we had this notion of area of a square from which we understood the notion of what a square or perfect square means. Now coming back to square root, it's the inverse of it. So say area of a square is 169 meters square, then what is the length of that side? So in putting it in this equation, this is 16 and this is square of some number a. And what would that number be? From our tables previously, we know that 13 into 13 is 169. So therefore, 13 square is 169, or square root of 169 is 13. So there, comes the notion of what a square root actually means. So, in very formal terms, a square root of a number, say n, is the number which, when multiplied by itself, gives n as a product. So, say m is the square root of n. Then m into n, m to m is equal to n, or m square is equal to n, and n is denoted by the square root of m. And that's how we show how it is. So now how should we find square root of a number? So the first method is finding square root through prime factorization. So let's understand this through an example of taking a square root of 324 through prime factorization. So we obviously know how to take the prime factorization. 324, that comes out to 162. 2 again, we have 81. 3, we have 27. 3 again, we have 9. 3 again, we have 3. 3, there goes 1. So 324 can be expressed as 2 into 2 into 3 into 3 into 3 into 3. Now let's make pairs of these. So that is 2 into 2. There comes 3 into 3 and 3 into 3 again. So square root of 324 would be taking out one of each of these pairs. So we have 2 into 3 into 3, which comes out to be 18. Therefore, square root of 324 is 18. And that's how we take out the square root through prime factorization method. Let's take a different kind of an example. So now we're gonna talk about this different kind of question where we have to check whether this number 2352 is a perfect square or not. And if not, then we have to find the smallest multiple of 2352, which is a perfect square. So what do we do in such a situation? So in such a question, we'll first take the prime factorization of 2352. We'll do this very quickly. So 2352 can be written as 2 into 2 into 2 into 2 into 3 into 7 into 7. Let's make the pairs. So we have a 2 into 2, another 2 into 2, and one 7 into 7. We know now that 3 is left out or is unpaired. So in order to get a multiple of 2352, we must multiply 3 to 2352 to get a multiple which is a perfect square. And let's find that out. So perfect square would be 235 into 3, which comes out to be 7056. And this is a perfect square whose square root would be, we'll take from above prime factorization, 2 into 2 into 3 into 7, which comes out to be 84. And that's how we solve this kind of a question. And similarly, if we change this to divided by, then only thing what we need to do is we need to divide 2352 by 3 to get the minimum number that needs to be divided to get to a perfect square. So that's the difference between different kind of question that comes in the exam. So that was the end of the prime factorization method. Now we are going to talk about the other method, that is the division method. Through this we can find out the square root of larger numbers, because prime factorization can become a lot tedious for a large number of numbers, and this acts as a very simple method to do it. So let's take an example and go step by step how we get through the division method. So let's find the square root of a large number 7056. So in this, first of all, we'll create this big bracket. So let's first put these numbers 7056, and then from the left hand side, from right to left, we'll place a bar on every digit. So right to left would be this way, and then we put a bar on these numbers, and we'll take the first pair of digit, which is 70 in this case, and find the greatest number whose square is less than or equal to 70. And for this, if we think about the table, we know that for 8 it is 64, which is just less than 70. So let's put that up. So 8 here and 8 on top, and then we have 64. We'll subtract that, and then we'll get 6. Now there's an interesting thing that happens. We'll take this digit and find the double of it, and then that will become 16. And then we'll put this one down, 56. So we have 656. And then we have 16. Then we have to find the largest possible digit to fill in the blank, which will also become the new digit in the quotient. So let's see what happens. So you have to find some digit that 160 something into something divided by 160 something into something would give us something that is less than 656. So we can do this with multiple trial and error. We can try 161 into 1, we can try 162 into 2, 163 into 3, and 164 into 4. And we see that on the fourth time it is exactly the same number. So we put 4 here and we've put 4 here, and then we get 656, and that comes out to be 0. So the square root of 7056 through the division method comes out to be 84. This is a tough kind of a question, so there needs to be a lot of practice to be done in order to get good at it. Let's do another big number. So let's find the square root of 55696. So let's put the numbers first. So we have 55696. So we'll put a bar from right to left, 9656, and then we have 5 that is left at the end. So we'll put it like this: 5, 5, 6, and 9, 6. So first we'll find the smallest number, that is whose square is smaller than 5. So that would be 2. So we put 2 here, 4, and then our subtraction, and then we get 1. Then when we bring down 156 as a new divisor, we double this 2, that comes out to be 4. And then we have to find 40 something whose multiple is less than 156. So we'll try 41 into 1, 42 into 2, 43 into 3, and so on. So we try 41, 84, and then we have 129. So that is less than 156. So we'll put that here. That comes out to be 129. And then again we get a divisor of 27, and then we bring down 96 again. Then we need to double this 3, and this comes out to be 4. That comes from before. 3, the double of 3 would be 6. So 4, 6. Now we have to find 460 something that is either divisible with 2796 or is smaller than 2796. So we'll do it again. 4, 6, 1 into 1, 4, 6, 2, 2, and so on. And we find through a lot of computation that 466 into 6 is equal to 2796. That is exactly that number. So we'll put 6 here and we'll put 6 here. And then we have 2796. And the whole thing comes out to be 0. And therefore, square root of 55696 is equal to 236. I hope that makes a lot of sense. If not, please do let me know in the comments below. Let's try another type of square root, and that is square root of a decimal. So this can be quite daunting for a lot of people, but we'll try it anyways. So let's find the square root of 12.0409, right? We'll try and find what should be the bars of each. So for decimals, the bar is different. So we start from the decimal point and we go away from the decimal point on each side. So here we have 0, 4 and 0, 9 as a pair. And on the other side of the decimal, we have 12 as a pair. So we'll write that down in that manner. Okay, so now let's find a number whose square is smaller than 12. So that would be 3. So 3 up here. And then we get 3 as the remainder. We bring down 0, 4 here. And we'll also put simultaneously the decimal. Then we again bring the double of it. So double of 3 is 6. And then we have to find something, 60 something, that is equal or smaller than 304. So 60, 61 into 1, 62 into 2, and so on. And we find that 64 into 4 works out to be 256. So we'll put that here. And then our remainder comes out to be 48. That is our new divisor. And then we again bring down 0, 9 here. And then doubling again. So a 6 remains the same. There's a doubling of 4. And the double of 4 is 8. Now we need to find something 680 something that is smaller or equal to 4809. So we'll find 681 into 1, 682 into 2, and so on. We find 687 into 7 comes out to be the exact same number, 4809. And then we put 7 on both here and we have 4809. And that gives us a 0 remainder. And therefore, the square root of 12.0409 comes out to be 3.47. I hope you understand this. I know this is very difficult, but if you do your practice, this would be very easy. Now let's make this a bit more difficult and try to find square root of a number which is not a perfect square. So let's try to find square root of 5 and we'll put it to two correct decimal places. So for this, we have 5.0000 because we need to put it for two correct decimal places. We need to find for three decimal places so we can correct for two decimal places. So we need 6 zeros behind it. And then we'll put the bars like this, going away from the decimal. Let's put that here, right? So let's find some square that is less than 5, and that is 2. That comes out to be 1. We put this point decimal simultaneously and bring down 0 here. We'll double 2, that is 4. And then 42 into 2 comes out to be something that is less than 100. And that is 84. We get the remainder of 16. And then we again bring down the zeros from above. I'll put the zeros here. And then we have 4 again. We double 2, that is 44. So we need to find 4 something that is less than 1600. Through our calculation, we understand that 443 is the best one. So 443 into 3 would come out to be 1329. And this would give a remainder of 271. Then we again bring the two zeros in this place. So we need to find something that is 2710, 27,100, something similar to that. And then we'll have 4 as same. We'll double 3, that is 6. So we need to find something 4,460 something that is kind of similar to 27,100. So through our calculation, we get to know that this is 4466 works the best. And then we put 6 here. And our final value is 26796. And then we get some remainder that doesn't really matter at this point of time. So that is 304. And we can go on and on with this depending on how many correct decimal places we want. So our approximate square root of 5 is 2.236. As we need it to be two correct decimal places, then we have square root of 5 is 2.24.
I hope you liked the video. Thank you for watching and stay tuned on the next part on cubes and cube roots.